Hello, good morning viewers. Welcome back to my channel. Today we shall be talking about the decibel scale, and we are also going to solve mathematical problems on decibel scale. Previously, we discussed about the topic sound wave and its impact on the environment. We had considered the meaning of sound wave and its applications. We also discussed about the three categories of sound wave. So today, basically, we will put all our attention on the decibel scale. Let's get started. The normal hearing range lies between two extremes, the threshold of hearing and the threshold of pain. The human ear detects sound energy at or within the audible range, which lies between the 20 Hz to 20 kilohertz. When I say kilohertz, I mean 20,000 Hertz. The human ear has a minimum amount of energy it can detect. So that minimum amount of sound energy the ear can detect is referred to as the threshold of hearing. And the maximum amount of sound energy that the ear can detect is the threshold of pain. So because of this wide range, intensities are usually measured in decibel logarithmic scale. So that will now take us to the sound intensity level. So whenever we are measuring sound, we use the sound intensity level, which is measured in decibel. What is sound intensity level? This could be defined in three ways. The sound intensity level is defined in just three ways. So the first is represented in equation 3 here. The second is represented in equation 4, and the third is represented in equation 5. Let's go back to equation 3. The sound intensity level is simply the ratio of the log of sound intensity produced, the ratio of the log of the sound intensity produced, and the reference intensity of sound, and the reference intensity of sound multiplied by 10. So it is written in the form of an equation. So you can see the I here represents the sound intensity produced, and I naught here represents the reference intensity of sound, which is a constant, which is of the order 1.0 times 10 to the power minus 12 watt per meter. So as I said earlier, this is the sound intensity at the threshold of hearing. We can as well define it in terms of power. And it is the ratio of the log of sound power produced to the reference sound power multiplied by 10. So this is the sound power produced, and this is the reference sound power. So you can as well define it in terms of pressure, as it is seen below. Let us look at this example. The example here says, find the intensity level of sound. Let me take this off so it won't confuse you. Or I put this as answer. Okay. So that would be our answer. Let's go back. Find the intensity level of sound from a radio set when it gives out sound at 10 to the power minus 8 watts per meter square. Let us use the board so that we understand better. So the question said, find the intensity level of sound from a radio set when it gives out sound at 10 to the power minus 8 watts per meter square. So we are looking for the intensity level of sound. The intensity level of sound, beta, is unknown. We'll put question sign. Find the intensity level of sound from a radio set when it produces. So this is the sound produced by the radio. Sound produced by the radio, I equals to 10 to the power minus 8 watts per meter square. Okay. All right. But don't forget that the threshold of hearing, I0, has the value of 1 times 10 to the power minus 12 watts per meter square. It is a constant. Now, from equation 3 or 4 or 5, which one should we use? You now see these ones are in terms of intensity. So we are going to use equation 3 because that one appears in terms of intensity. So the intensity level of sound, beta, equals to 10 log I all over I0. We are now going to substitute these values into the expression here. So we would have beta equals to 10 log what is I? 10 to the power minus 8 all over 1 times 10 to the power minus 12. In place of I0, we now replace the second one. Hope you're following. When we simplify this, we will get beta equals to 10 log 10 to the power 4. And this will give us a final answer, which is 40 decibel, which is the same as what we had. So try this and see. Try it and see. Okay, so let us go to the next question. Check this out. Okay. The question says, a noisy grinding machine in a factory produces a sound intensity of 1.0 times 10 to the power minus 5 watt per meter square. So that is the sound intensity produced by a machine. The first option here says calculate the decibel level of this machine. So we are going to calculate the decibel level of this machine. B part of it says the new intensity level when the second identical machine is added to the factory. So now, the first machine was functioning at a certain decibel level. They now bring in another machine that functions the same way as that one. So the question is, what would be the identical value, the power produced, or the noise level intensity produced by that machine? We are going to see it. Then the third option here says, a certain number of additional such machines are put into operation alongside the two machines. So what if other machines are being added? Find the sound intensity. So if other machines are being added such that it runs at this rate, it produces the sound level at the rate of 77 decibel. Find the sound intensity. We are going to take it one after the other. Let me copy this and then take it to the board. Okay, so we had that a noisy grinding machine in a factory produces a sound intensity of 1.0 times 10 to the power minus 5 watt per meter square. So we write here, I, sound intensity produced is 1.0 times 10 to the power minus 5 watt per meter square. Okay. Question now said, calculate the decibel level of this machine. And we should find the decibel level of this machine, which is beta. Calculate the decibel level of this machine. Before I go to B, don't forget that I naught equals to, what's the value of I naught? 1.0 times 10 to the power minus 12 watt per meter square. Okay, so the decibel level of the machine, beta, equals to 10 log I all over I naught so this is equals to this is equals to 10 log into what is I? 1.0 times 10 to the power minus 5. 1.0 times 10 to the power minus 5 all over I naught. 1.0 times 10 to the power minus 12. So we are going to substitute I naught here. 1.0 times 10 to the power minus 12. Okay. So the next step would be beta equals to 10 log into what? Look at this. This one will cancel this one. One will cancel one here. From indices, this 10 to the power minus 5 divided by 10 to the power minus 12. This is the same thing as 10 to the power minus 5. They divided in indices. They use minus, then 10 to the power minus 12. So this would be into minus 12. All right, minus times minus here becomes plus. So this expression would be 10 to the power minus 5 plus 12. And this will give you 10 to the power 12 minus 5. And the same thing is 10 to the power 7. Okay, so here we are going to replace 10 to the power 7 here. When we simplify it, we will get that beta is equals to 70 decibel. This I would like you to try it on your own to also see. So we have solved the first problem here, A, and we have that our answer is 70 decibel. So I'm going to shift it aside so that we can continue. And look at the questions and the steps I have used, because I'm going to wipe this one off. All right. Please stay on the line. I'm still with you. Okay, so A, we have solved A, and our answer is 70 dB. Let's go to the next question. B, the new intensity level when the second identical machine is added to the factory. So the first machine was functioning at this rate. They now decided to come with another machine. Remember, the sound intensity produced by the first machine was I. I equals to 1.0 times 10 to the power minus 5 watts per meter. According to the equation, this is where I got it from. Fine. Don't forget the threshold of pain, I naught. 1.0 times 10 to the power minus 12 watt per meter. So another machine has been brought to the factory, meaning that we are going to multiply this by 2, or we add this value. So this would be the output. This would be the sound produced by the machine. So if two machines are functioning at this rate, so we'll now add this or multiply this by 2. So if I do that, what do we get? This will give us let me wipe this so that I will have space. When we multiply that by 2, this is what we will get. 2.0 times 10 to the power minus 5 watts per meter square. Okay, so we are still going to use this expression beta. So this will tell us the amount of intensity that is being produced now when we have reinforced a new machine into the factory. Like if you see the equation once again, so you understand it, the new intensity level. So we've solved for the intensity level for the first machine alone. Now, an identical machine that it functions the same way has been brought. So this one is multiplied by 2. So we now get this to be the output. Okay, so here we would have 10 log I all over I naught. When we substitute the value of I to this one and then I naught to this, we will have beta equals to 10 log ten log 2 times 10 to the power minus 5. I hope you are following. All over 1.0 times 10 to the power minus 12. All right. I would like you to simplify that. Let's see what we will get. This will amount to 10 log 2 times 10 to the power 7. 2 divided by 1 is 2. Then from indices, here we'll have 10 to the power minus 5 minus 12. Fine. So this will give us 10 to the power minus 5 plus 12, which is this value here. I hope you are following. When you simplify this, you get 10 to the power 7 here. So 2 divided by 1 is 2 here. Then this one here, this one divided by this gives you this value. When you simplify it, all you get beta equals to check my calculator. Okay, 73 decibel. So this gives the new intensity level when the second identical machine has been added to the factory. The first one was 70. They now brought another machine that functions the same way as that one and increased to 73 decibel. Because of space, I'm going to wipe this. Okay, so the first machine produced intensity, sound level intensity at the rate of 70 decibel, and two identical machines produced sound level intensity at the rate of 73 decibel. Let's see what the third question is saying. A certain number of additional such machines are put into operations alongside these two machines. So more machines were now added. When all the machines are running at the same time, the decibel level is 77 dB. So the sound level the machines, or the total number of machines produced, is 77 decibel. So the question now is, find the sound intensity. Which one is the sound intensity? We are to look for I. We are to solve for I. So that would be what we are looking for. Since they have given us this value here, so beta here equals to 77 decibel. Don't forget that threshold of hearing I naught equals to what? 1 times 10 to the power minus 12 watt per meter. All right. So remember that beta equals to 10 log I all over I naught. Now, since we are looking for I, we are going to solve for I in this question. I would prefer you just solve once and for all, and then you get the formula, which you can use at any point in time. So let me start solving. From here, we have 10 here. If we divide both sides by 10, we will have beta all over 10 plus 10 decibel equals to log I all over I naught, not I over I naught. So for us to clear this log, this has to be raised to an exponential. So we will have 10 to power beta all over 10 equals to I all over I naught. So the log has been eliminated. And then from here, we can put over 1, and then we cross multiply. When we cross multiply this, for us to get I, we will have I naught times 10 to power beta all over 10 equals to I. Okay, so this would be the new expression, but it's not proper for me to write it this way. So what I'm going to do is I will plane this and bring it over to this other side. So now I have I equals 2, which is the same thing as I naught 10 exponential b all over, or beta all over 10. So this is the new expression. Clean this one. We have I here equals to. So anytime we are asked to find the sound intensity, we are going to use this expression instead of going through the process of solving again. Okay, so to find the sound intensity, and another thing I would say is, if we are solving for the sound intensity in terms of power, in terms of pressure, we still use the same step to manipulate it, and then it gives us what we are going to use to solve the problem. So it's meters square. All right, so here we have I. Since we are looking for I, this will be I equals to, what is I naught? 1 times 10 to power minus 12 from the formula times 10 times 10 to power, what is beta? 77 all over 10. All right. When you solve for this, the whole expression will give us this answer equals to we have 5 times 10 to the power minus 5 watts per meter square. Watts per meter square. Okay, so that is all we can solve for this very problem. That's the final answer. So the final sound intensity, or the sound intensity produced by all the machines, is written below here. You can also try it and see. Let us go to the next question. Okay, welcome back. So the last question here says, suppose a manufacturing plant has an average sound intensity level of 97 decibel created by 25 identical machines. So this is the average sound produced in a factory. It's very high, 97 decibel. And this is as a result of a combination of 25 identical machines. So the options says, find the total intensity created by all the machines. So we are asked to find I, just as we have done the first one. Then the B part says, find the sound intensity created by one such machine. So we are also going to find the sound intensity that one machine can produce. After finding the first one here, sound intensity for all, we are now going to find sound intensity for just one of those machines. And the C part says, what's the sound intensity level in decibel if 5 such machines are running? Then we are also going to find the sound intensity for 5 machines, which will help us to find the sound intensity level in decibel. Let's go back to the board. Okay, welcome back. So the question says, suppose a manufacturing plant has an average sound intensity level of 97.0 decibel created by 25 identical machines. So solution, simply say beta equals to 90 97 97 decibel. So this is produced by 25 machines. It's produced by 25 machines. Okay. Find the total intensity created by the machines. Find the total intensity created by the machines. So we are to find I, the total intensity created by the machines. But don't forget that I naught is 1 times 10 to power minus 12 watt per meter square. Okay, so if we are solving for this, I will not go through that protocol as I did the first time. I will only use the expression I equals to I naught times 10. What's wrong with this thing? I naught times 10 to power beta all over 10. So all we need to do is just to substitute directly into this expression. So here we'll have 1 times 10 to power minus 12 I naught, the value for I naught, and now put it in place of I naught. This one is 10, so you now write times 10. Then we have exponential beta over 10. What is beta? 97. So we write 97 divided by 10. I hope you're following me. When you simplify this, you will now get I equals to 5 times 10 to power minus 3 watts per meter square. So this is the sound intensity produced by 25 of these machines. What does that mean? It means that if we multiply a single value or a single amount of intensity by 25, we will get this value. Okay, let's check the next option or the next question. The next question says, find the sound intensity created by one such machine. Okay, so if 25 machines produced this intensity, what value would one of them produce? Okay, so this is B. We will simply say, since it is 25 that produced this value, we will say 25 times I, which is this value of I, is equals to the intensity, which is 5 times 10 to power minus 3 watts per meter square. Now, what do we do? Since we are looking for I, we are going to divide both sides by 25. So when we do that, we will have I equals to 5 times 10 to power minus 3, 5 times 10 to power minus 3 all over 25. So with this, we would be able to know the value of one machine, what one machine can produce. So this will now be equals to 2 times 10 to power minus 4. Intensity is measured in watt per meter square. Don't forget SI unit. It's very important. Watt per meter square. All right, let's go to C. What's the sound intensity level if 5 such machines are running? What is the sound intensity level if 5 such machines are running? Since we have the value for one machine, so all we need to do is to use this value and multiply by 5 for us to get the value of what 5 machines can produce. So what's the sound intensity level in decibel? So this will help us to get the sound intensity level in decibel if 5 such machines are running. So when we multiply this I by 5, it will give us the intensity, sound level intensity, which we are also going to use to generate the value for the sound intensity level. Let me clean this. Okay, so the sound intensity produced by a single machine from what we have solved is I equals to, what do we have there? 2 times 10 to the power minus 4 watts per meter square. This is what a single machine can produce. So 5 such machines will produce 2 times 10 to the power minus 4 times 5. And this would give us I for 5 machines equals to 1 times 10 to the power minus 3 watt per meter square. So this is what a single machine can produce. But the question said we should find, so what is the sound intensity level in decibel? So we are not looking for I, but rather we are looking for beta. So simply use the expression is 10 log I for 5 machines. Let me put 5 here so you know. Okay, so for 5 machines all over I naught. Of course, we know that this one is a constant. So this would be beta equals to 10 log into 1 times 10 to the power minus 3 all over 1 times 10 to the power minus 12. Okay, so this would give us beta equals to, when you use your calculator to simplify it, we'll get 90 decibel. Thank you very much. I think we have come to the end of today's session. Please, if you enjoyed our exercise today, please, I want you to encourage us by pressing the subscription button, like, and also share to people that you know. Thank you very much. I really appreciate your stay. Have a wonderful day.